Namaste, this is Upendra, physics faculty, having 12 years experience in NEET program. So, and currently I am staying in Hyderabad, working location is also Hyderabad right now. So, today I am discussing about the concept of time period of simple pendulum, time period of simple pendulum in simple harmonic motion. So, I want to try to find the time period of simple pendulum in a simple harmonic motion, and in this concept I will try to discuss about the two applications. The first application is nothing but the simple pendulum suspended in a moving system, suspended in any moving system. And the second application I am discussing about the same simple pendulum exists inside of liquid. So, or suspended inside of the liquid. So now, before entering into the concept, I will try to discuss about some basic concepts about the oscillatory motion. So, minimum requirement to learn the time period of simple pendulum in simple harmonic motion. The minimum requirement is, first of all, we have to try to learn what about the displacement of a particle. Displacement of a particle in simple harmonic motion, it is symbolically represented by y, and the second one is velocity of a particle and acceleration of a particle A, and what about the time period in a simple harmonic motion or an oscillatory motion, and what about the frequency of a particle. What about the frequency of a particle? So, I will try to discuss with you the relation between each and every variable first of all.
కెమెరాకల్ చూసి ఎక్స్ప్లెయిన్ చేయండి సార్. ఎక్స్ప్లెనేషన్ ఒకటే, కెమెరాకల్ చూసి ఎక్స్ప్లెయిన్ చేయండి.
So, first of all, let us try to take the displacement of a particle. So, displacement of a particle in any oscillatory motion. Oscillatory motion is nothing but a to and fro motion. Means one particle, it is existing at this position. About that position, it will try to displace at one side of one position, and again it will come to backward direction, and again it will try to displace other side of this position. Means actually three positions are existed here. This is the mean position of a particle, or it is also called as an equilibrium position of a particle. And it will try to displace, means initially the particle is located at mean position. The particle is located at mean position. That particle will try to displace from O to A position, and again when it will reach to A position, this A position is called as an extreme position. This A position is called as an extreme position. Again, the particle come back from A position to O position, and again it will try to displace from O position to opposite side of that position, that is B position, means extreme position, another extreme position. Means another extreme position, one extreme position we have to take on A, because here A is nothing but an amplitude of a particle. Amplitude means that is nothing but an maximum displacement of a particle. Means the particle reaches from mean position to maximum displacement when it will reach. That maximum displacement point is nothing but an amplitude of a particle, and other side it is nothing but another maximum displacement, another opposite side of particle displacement is nothing but another extreme position here. Again the particle reaches initial position from B position to say O position, then one to and fro motion completed in this case. So this is the actually oscillatory motion or simple harmonic motion. Observe how the path it is existed. The path it is existed in a straight line. So remember, to find the displacement of a particle in simple harmonic motion, so we will use or we will try to take on the help of a uniform circular motion. Means we have to try to assume the particle is in uniform circular motion. The particle is rotating in uniform circular motion. Then the projected point, whatever it is connected, that is the central point of the circular path, that will do to and fro motion. Means here particle is doing circular motion. Particle is doing circular motion, uniform circular motion. Then the projection point, whatever it is connected, this is the particle is doing circular motion, and the projection point, whatever it is connected to the particle, that projection point will reach us maximum position. Then again it will come to mean position, again it will go to the another maximum position. Means two extreme positions whenever it will cover, and again it reaches to mean position. Means the particle, when it will covers one complete circular path within a time period t, then the projection point O, it will complete one oscillatory motion. Means one to and fro motion. Based on that one, we have to try to take on the displacement of a particle. Based on that one, we will derive the displacement of a particle. Y is equal to A sine omega t. Then we have to use this displacement of a particle. Y is equal to A sine omega t, means whenever the particle starting from mean position at this point, means from the mean position, the particle starting point is the mean position, then it reaches the maximum position, means up to like this. Here it is there in clockwise direction. The starting point of the particle is from mean position. Then the displacement of particle is Y is equal to A sine omega t. Otherwise, initially the particle starting point is from maximum position. Then we have to use the displacement of a particle. Y is equal to A cos omega t. If the particle starting position is from the maximum position, then we have to use the displacement of a particle. Y is equal to A cos omega t. So in the given content, whatever was taken, the starting position of a particle is mean position. That's why it was taken. Displacement of a particle in simple harmonic motion is Y is equal to A sine omega t. This is the first variable. And another variable or another parameter, let us try to take the velocity of a particle. The velocity of a particle, V is equal to rate of change of displacement, that is dy divided by dt. Means d by dt of, let us try to differentiate A sine omega t. Remember in this case, in this equation, what about the y? Y means displacement covered by the particle, and A means amplitude of the particle. This is amplitude of the particle, and omega is a angular velocity. means here it is the particle is doing in circular motion. It is nothing but a uniform circular motion, means velocity, angular velocity is a constant in this case. So in this, amplitude and omega both are constant values. When you try to differentiate this one, we will get V is equal to A sin omega t. You have to differentiate. It will be changed as an cos omega t. Again, constant we have to put outside. And finally we will get V is equal to A omega cos omega t. Means this equation will give the relation between the velocity and time taken the particle to change the position from one point to another point. Then now let us try to rewrite the equation in another formation. V is equal to A omega cos omega t. We have to try to write down in another way, that is 1 minus sin square omega t. Let us try to take on this amplitude inside, then you will get omega square root of a square minus a square sin omega t. A square sin square omega t. So observe in this case, what is a square sin square omega t? A sin omega t is a displacement of a particle in simple harmonic motion. Then V is equal to omega square root of a square a sin omega t. Substitute the y, then you will get y square. So V is equal to omega square root of a square minus y square. So this will give the relation between the velocity of a particle in SHM and displacement of a particle in SHM. Now observe in this case, in the given picture, three positions are existed, or mainly two positions are existed. One is a mean position and another one is an either any extreme position we have to try to take. So the particle, when it is existing in mean position, what about the velocity? When the particle, when it is in extreme position, then what about the velocity in this case? Let us try to take when the particle is at mean position. Observe in this case, the particle is at mean position, the displacement of a particle at a mean position is 0. So y is equal to 0. Then what about the velocity of a particle? Take the velocity of a particle formula, omega square root of a square minus y is 0. So that is 0 you will get. So V is equal to omega square root of a square, omega square root of a square, square and root will get cancelled. So we will get omega into a. So at any time you have to take a mean position. V is equal to omega into a. So this is the maximum value of the velocity. This maximum value of the velocity, at what position it is existed? Mean position it is existed. And another position here it is extreme position. Another position here it is extreme position. At an extreme position, what about the displacement of a particle? Then y will be increased gradually. When it will reach us at a point A, then y is nothing but a maximum displacement covered by the particle. That maximum displacement, y maximum is equal to nothing but an amplitude A. So at an extreme position, what about the y? Y is equal to y max, that is equal to A. Let us try to substitute in the formula. V is equal to omega square root of a square minus y square means y maximum, that is nothing but again a square minus a square, you will get completely it is 0. Means at an extreme position, observe in this case, the velocity of a particle is minimum, that is 0. That is 0. So this is the concept of velocity. Then let us try to go the next parameter, that is acceleration of a particle. So y is equal to a sine omega t and v is equal to a omega cos omega t, and that is equal to omega square root of a square minus y square. And other one, next parameter I am trying to find, that is acceleration of a particle in simple harmonic motion. Acceleration of a particle in simple harmonic motion. Acceleration A is equal to, we know, rate of change of velocity of a particle. That is dv divided by dt. So d by dt of, so what is the formula? A omega cos omega t. You try to substitute this one, a omega cos omega t. So d by dx of sin nx is equal to cos nx. So d by dx of dx of cos nx is equal to minus sin nx into n. This is the formula. Let us try to apply this one. So acceleration A is equal to A omega. So minus, so d by dt of cos omega t is minus sin omega t into omega is constant. Let us try to put outside. Then minus A omega square sin omega t. Finally we will get here. Let us try to rewrite this one. Minus omega square A sin omega t. Then now you have to observe in this case, what is again A sin omega t is what? A sin omega t is nothing but a displacement of a particle in SHM. Then A is equal to minus omega square A sin omega t is nothing but an y in this case. So observe this parameter. This in this case, this will give the relation between the acceleration and displacement of a particle. Now here what is the minus represents? So negative here minus represents the acceleration is always acts opposite direction of the displacement of the particle. Means the particle starting position is mean position. The particle starting position is mean position. It will try to move from O to A. This is displacement of a particle. But from A to O, the acceleration of a particle will act. Means the displacement is from O to A, but always acceleration will try to act towards the mean position. So that's why this displacement and acceleration both are acting opposite to each other. Then A is directly proportional to minus y here is. Let us try to observe that one. So why it will come whenever it will reaches the maximum position, means extreme position. The particle velocity will be 0. Then what about the acceleration at mean and extreme position? Let us try to observe. In mean position, we know the displacement of a particle is 0. Then y is equal to 0. Then what about the acceleration? Acceleration is equal to omega square into y, that is 0 you will get. Means at a mean position y value 0, a value is equal to 0, means the minimum acceleration is existing at mean position. What about the extreme position? In extreme position, the displacement of a particle is maximum displacement, that is equal to a. Let us try to substitute in the formula. Acceleration a is equal to minus omega square into a, you will get here. Means you have to try to observe in this case a is equal to minus omega square a, where you will get at an extreme position, this is the maximum acceleration required by the particle at extreme position. In this velocity and acceleration, in both cases, let us try to observe. At a mean position, velocity at a mean position, y is equal to 0, velocity is maximum. In the mean position, velocity is maximum, but there is no acceleration. And in the extreme position, observe the velocity, velocity is minimum means at a mean position velocity is 0. Sorry, at extreme position the velocity is 0 means whenever the particle reaches the extreme position the velocity is minimum, it is existed means there is no velocity. But what about the acceleration at extreme position? Acceleration is maximum at extreme position means in this case velocity and acceleration both are not dependent each other. So acceleration is not depends on the velocity in this case. That's we have to observe. And the next one I am trying to explain. What is the reason to the particle taken reverse direction when it reaches the extreme position? The particle reaches the extreme position, but at that point the acceleration will be maximum. Then acceleration always acts towards the mean position. Means the meaning is the particle requires somewhat force. That force is nothing but an here restoring force. Whenever the particle will disturb from mean position to extreme position. So at the time of reaching the extreme position, one of the force it is required, that is nothing but an restoring force. So that restoring force, by using the Hooke's law, that restoring force is always directly proportional to the negative direction of the displacement of a particle. Means from O position to mean position O to A position, this is the direction of the displacement, but restoring force always acts away from the extreme position or always acts towards the mean position. That's why you have to try to apply. Let us try to take one small system. You have to connect a block of mass of the block to the spring. When you try to apply your external force on this one, you have to apply the external force on this one, release this one, what happened? So like this, it will oscillate. Means about one mean position, it will try to oscillate forward direction, backward direction, like this. Why? When you release the block, after displacing, when you release the block, automatically block will come backward direction. Means what happened? Inside of the spring, automatically some restoring force is generated. That restoring force is always opposite to the direction of your external force. Means displacement of a particle, the displacing direction of a particle is existing in the direction of the external force. But whatever restoring force it is existing, it always acts towards the mean position, or it always acts opposite to the direction of the displacement covered by the particle. So that's why F is directly proportional to minus x. X is nothing but a displacement, or we have to use y also. No issues at all. I am using y here. Y, F is directly proportional to minus 1. Let us try to remove the proportionality. So one of the constant I am taking here, this is nothing but a force constant. Here K is nothing but a force constant. So F is equal to minus K into Y. This is the restoring force. Now let us try to take what is the force. Force is nothing but a mass into acceleration, that is equal to minus K into Y. So what you know about the force, general formula of the force is mass into acceleration. So which acceleration, which force it is nothing but a restoring force, that is mass into acceleration, mass of the block into acceleration. A is equal to, what is the acceleration? A is equal to minus omega square into y. Let us try to write down minus omega square into y is equal to minus k into y. Now y will both sides cancel, negative sign will get cancelled. Then what about the omega square? Omega square is equal to k divided by m. Then omega, angular frequency, is equal to square root of k divided by m. So this is the value of omega in standard value of omega in simple harmonic motion. Then what about the next parameter? The next parameter is time period. Time period t, by using the uniform circular motion, time period t is equal to, we know, that is nothing but an angular displacement covered by the particle. How much angular displacement from initial to this one? This is 2 pi, 360 degrees, 2 pi radians it is. 2 pi divided by omega angular velocity. So 2 pi by omega. So 2 pi divided by omega is square root of k divided by m. Then t, time period means what? The time taken to complete one oscillatory motion. The time taken to complete one to and fro motion completely. So that is 2 pi square root of m divided by k. Here m is nothing but the mass of the particle and k is nothing but a force constant in this case. This formula, let us try to remember. T is equal to, so omega is equal to square root of k divided by m, and time period t is equal to 2 pi square root of m divided by k. These two formulas let us try to remember. And what about the frequency? Frequency is nothing but the reciprocal of the time period, means the number of oscillations generated within a unit of time period or within a second, means that this is the reciprocal. Frequency is the reciprocal of the time period. The frequency nu or f is also symbolic representation, and u is equal to 1 divided by t. The units is hertz, we have to use the SI units. So these are the minimum requirements to learn the time period of simple pendulum in simple harmonic motion. Now let us try to take, so the time, first one I am taking here, the time period of simple pendulum in simple harmonic motion. This time period we have to find by using different systems. But I was choose this system. This is one of the system, right? So we know the simple pendulum, how it is existed. This is the rigid support actually, and one of the suspension point here it is existed. From that suspension point to one of the pendulum like this, it is hanging. So practical representation it is there. In 11th class we have to do the practical also. So this is the bob and this is the light inextensible string. Light inextensible string here is there. It is not as strong. It is a light inextensible string, and this one is nothing but a bob of a simple pendulum. The entire system we have to call it is a simple pendulum. This simple pendulum, when it will try to do a simple harmonic motion, then how to find the time period? Means the time taken to complete the bob 1, 2, and again it will come to mean position, again it will go to extreme position. Let us try to redraw the picture. So this is the mean position. Now the particle or bob existing in the mean position. When you try to disturb this one, it will reach one of the extreme position, like this. This is extreme position. Again it will come back, again it will move to the another direction. This is another direction. So this is another extreme position. So before entering into the topic, I am telling to you what about the angle between the mean and the extreme position. The angle between mean and extreme position, theta, in this case the angle theta is very small. So this is very small actually. So for example, let us try to take a pendulum like this. Here it is there. It will try to displace like this, with respect to a smaller angle. This is, let us observe how much small it is angle, very small angle here is. Then what happened? The displacement of a particle from mean to extreme position, how it is there? The path here it is there, it is a straight line, it is a linear motion. But why we have to draw like this means, when you have to draw like this, it is for the zooming purpose, it is for the explanation purpose I was drawn here. Like this here it is not existed, yes it is existed, because when you have to take it like this, it is a circular path, it is an arc. See, this path is nothing but an arc of a circle, means we have taken all the parameters related to the angular. So angular displacement, angular velocity of the particle, like that we have to take. So but the main content is the particle will do the linear path, here it is, but visual purpose I want to draw a big picture. That's we have to remember. So first of all, let us try to take one rigid support here is there, and let us try to take one pendulum, the bob pendulum, the pendulum bob, here it is existed, it is at mean position, it is at mean position. The length of the string is L, and whenever it will disturb, then the particle, the bob reaches its extreme position, means from mean position to, here it is the extreme position, here it is the extreme position, from here to here it will reach. Means how much displacement it is? Let us consider this is an x displacement covered by the particle from mean position to extreme position, and it makes an angle theta vertically, that is theta angle it was generated, and tension here it is existed in the string, that is T tension. Now, so the 3 points let us try to remember. To find the time period in any system, so the 3 points mainly required. The first one is nothing but what about the mean position of a particle? What about the mean position of a particle? Means in the mean position, the net force experienced by the particle is equal to 0. And the second one is nothing but forces to find the force at an extreme position. Find the force at an extreme position. Which force it is existed at an extreme position? Whenever the pendulum reaches at an extreme position, the pendulum will try to move towards the mean position again. The pendulum, whenever it will reach its extreme position, the pendulum will try to move towards the mean position again. Means in the bob, automatically somewhat force it is existed. How much force it is existed? That force we have to find at an extreme position. That force is nothing but what? That is nothing but a restoring force. Restoring force. F rest, I want to write like this. F rest. F rest means the bob is at rest position normally. The bob contains restoring force here. So the third point, let us try to compare the equations by using the standard equations of simple harmonic motion. F is equal to minus kx, we derived already, and the time period t is equal to 2 pi square root of m divided by k. So substitute in this case, we will get the time period of the particle. Let us try to follow these 3 steps. We have to try to find out the time period of a particle of simple pendulum in a simple harmonic motion. The first step, let us try to observe. So at a mean position, the particle is at rest position right now. Then what about the net force acting on the particle? The net force acting on the particle is mg, right? So then what about the restoring force? From the given picture, let us try to observe from the figure. What about the restoring force in this case? Let us try to taken the net force acting on a bomb at an extreme position. This is the weight of the bomb. Let us try to resolve the weight of the bomb along the tension in a string. This is the angle theta, here it is existed. Theta is very small here. This is mg cos theta, and another component of the weight of the bomb, that is mg sin theta. So what you understood here, the restoring force in the given picture is nothing but an mg sin theta. It will act, means this force will act always towards the mean position. So when it reaches the extreme position, the tension in the string balances the one of the component of the weight of the object. T is equal to mg cos theta, and the restoring force, it is always acts towards the mean position. That is F is equal to mg sin theta. I was explained already to you, this theta is very small. At that time only the particle had simple harmonic motion. Otherwise, if theta is very large, it is not a simple harmonic motion. Remember this one. So if theta is very small, if theta is small, then theta is sin theta is nearly equal to theta, is similarly equal to theta. Then F is equal to mg into theta, that is equal to, observe the figure, theta is equal to, let us try to observe, this is an arc, so angle is equal to arc divided by radius. Then what about the theta value? Theta is equal to x divided by L. So now substitute this angle, so mg into x divided by L, the displacement of a particle from mean to extreme position, and restoring force F is acts towards the mean position, means both are acting opposite to the direction, then this is minus x divided by L. So restoring force F is equal to minus mgx divided by L. We found the restoring force. The step is over. Let us take the next step. Let us try to compare this restoring force with the standard equation of the simple harmonic motion, that is F is equal to minus kx. This is first equation. This is the second equation. This is the standard equation of the simple harmonic motion. Compare 1 and 2 equations. 1 and 2 equations. Compare 1 and 2 equations. That is minus kx is equal to minus mgx divided by L. That is minus mgx divided by L. Displacement x will get cancelled. Negative signs will get cancelled. Then k is equal to mg divided by L. This is the force constant K effective, what we got here. Then finally we have to take T is equal to 2 pi root m divided by K. This is, you know already this one. This is time period of a particle in simple harmonic motion. Standard equation, that is 2 pi root m divided by K. Let us try to substitute this K. So 2 pi square root of m divided by mg by L. So this is mg divided by L. M will get cancelled. Then you have to rewrite this one. Time period of simple harmonic, time period of a simple pendulum in simple harmonic motion. T is equal to 2 pi root L divided by G. So what we got here? So T is equal to 2 pi square root of L divided by G. observe this formula, so what we found, the time period of a simple pendulum will not depends on the mass of the bob, will be depend on only length of the string. That's how to remember. So this is the first main formula to find about the time period of a simple pendulum in simple harmonic motion. Now we have to go through the applications. Right? Let us try to take in the first application. So many applications are there, but I am taking two applications, main applications for the NEET level program. So application 1 here it is. So the simple pendulum, is suspended in a moving system. Right? So now I want to try to time period. For example, let us assume this is lift. Now imagine the simple pendulum is suspended from the suspension point. Here it is the suspended point. Here it is there. From this suspended point, I was arranged like this a bob. So let us try to imagine. So the acceleration of the entire system, because this is a lift actually. Inside of the lift bob, here it is existed. Now the lift is in acceleration. Then what about the time period of the simple pendulum in this case? So first of all, let us try to observe. This is a non-inertial frame of reference. This is a non-inertial frame of reference. Whenever it is a non-inertial frame of reference, then one force it is existed, that is pseudo force it is existed. So pseudo force existed in which direction? The pseudo force is existed on a bob opposite to the direction of the total system. So the total system lift is accelerated in upward direction. Then the pseudo force existing on a bob in always downward direction, because downward direction is the opposite direction of the accelerated motion of the entire system. So bob requires a pseudo force in the downward direction, that is m into a, plus another force also it is existed, that is weight of the bob m into g. It's totally m into a plus g or g plus a. This much of force it is experiencing at an equilibrium position. So at a mean position, the force experienced on the bob mg plus ma is equal to 0. Means net force acting on the bob here is equal to 0. When you try to take a tension in this case, this is a tension. So tension is equal to mg plus ma, but net force always is equal to 0 at a mean position. So whenever it will disturb, so the particle inside of the system, when it is changed its position from mean to extreme position. At an extreme position, the angle theta is very small here. So the length of the pendulum, here it is, and this is the tension existing in the string. Then now, so the weight of the bob, here it is. Let us try to resolve all the components. That is nothing but an m into g plus a total force it is experiencing. And here, let us try to resolve this one, mg. So m into g plus a cos theta. And another component of the force, it is acting always towards the mean position, that is m into g plus a sin theta. So this tension and m into g plus a cos theta balanced forces. Then what about the another component of the force, m into g plus a sin theta? This m into g plus a sin theta will try to move the bob towards the mean position. Means it will act as a restoring force. Now the second step, restoring force of the bob is equal to F, restoring force is equal to m into g plus a sin theta. Then what about sin theta here? When theta is very small, then sin theta is similarly equal to theta. Mathematically it is proved. So F, restoring force, is equal to m into g plus a sin theta is very small. Theta is very small. It is theta. Then theta is equal to, already I was told to you, it is a x displacement covered, means theta is equal to x divided by L. Let us try to substitute that one, m into g plus a into x divided by L. But that x displacement is opposite to the direction of the restoring force. That's why it is minus x divided by L. So restoring force F is equal to m. So minus m into g plus a into x divided by L. So this is the restoring force, acts towards the mean position always. Now let us try to take on the third step. Let us try to compare with the main equation of the simple harmonic motion, that is F is equal to minus kx. So this is first equation, this is second equation. Now compare the two equations. Now compare the two equations, that is minus, compare 1 and 2 equations. 1 and 2 equations. Minus kx is equal to minus m into g plus a into x divided by L. So this is negative sign will get cancelled, x will get cancelled, then k is equal to m into g plus a divided by L. This is the force constant whatever we got. Now let us try to take on the standard formula of a simple harmonic motion. So T is equal to 2 pi root m divided by k here is there. Now let us try to substitute that one. So T is equal to 2 pi root m divided by k is nothing but an m into g plus a divided by L. M will get cancelled. That is equal to 2 pi root L divided by g plus a we got here. That is the time period of a simple pendulum in simple harmonic motion. That simple pendulum existing in the lift, means that is in moving body. So whenever it is existing in the moving body, that is under an inertial frame of non-inertial frame of reference. That's why it experiences a pseudo force. So that's why we got the time period. So T is equal to 2 pi root L divided by G. So by using the standard formula, T is equal to 2 pi root L by G. So what you observe in the two cases, when the pendulum is in A, so it is 2 pi root L divided by G. Whenever you have to take on the same pendulum inside of the lift, when you try to hang the pendulum inside of the lift, it is experiencing pseudo force, because of that one, that G could be effective. That G could be effective. That's why we have to write P is equal to 2 pi root L divided by G effective. Right? So this is the concept of one of the application by using the simple pendulum main concept. So well, let us try to take the same system. It is accelerating in the downward direction. When the same system it is accelerating in the downward direction, then formula, what about the G effective? Let us try to change the simply G effective is equal to, whenever the total system is accelerating in the upward direction, means the bob experiencing pseudo force, acceleration of a system is in downward direction, then pseudo force,
Last 10 minutes.
pseudo force acting in the upward direction on the bob. So this is the concept of that one. At this situation, G effective is nothing but a G minus A we will get here. Right? So this is the one of the application. Now
మొత్తం చెప్పేసాడు సార్ మీరు అది కూడా వస్తుంది మొత్తం పాస్ అయింది ఏం కాదు.
So now another application is there.
Last 10 minutes.
That is application 2. Exactly 1 hour.
1 hour కంటే ఎక్కువ అనవసరం. 1 hour సార్.
Problems. So the second application here it is. Let us try to take the pendulum, the simple pendulum. Second application, the simple pendulum is doing simple harmonic motion in liquid. Simple pendulum is existed in liquid. What happened? How to do the simple harmonic motion? When it is doing simple harmonic motion inside of the liquid, so what about the time period at that situation? Again I am trying to find the time period in that situation. So let us try to observe. So one of the liquid, let us try to take here. So this is liquid, here it is existed. So now let us try to hang one of the pendulum inside of the liquid. So it's a rigid support. Now what about the force? Here it is. It is at mean position. The weight of the bob existing at an equilibrium position, that is mg, it is acting in the downward direction. Whenever we have to try to displace the bob, means let us try to observe, it has displaced x displacement, then it reaches the extreme position. It is experiencing different forces, it is experiencing. So what forces it is experiencing? It is a mean position, it is the extreme position, means angle theta here it is existed, it is the x displacement of a particle. So now it is experiencing, how many forces it is experiencing? Two main forces it is experiencing, that is weight of the bob and the liquid here it is existed. The liquid here it is existed. Liquid will try to apply one of the force, that is buoyancy force. So it is experiencing B force, buoyancy force also it is experiencing. Let us try to assume sigma is the density of liquid and rho is the density of bob. Rho is the density of a bob. Let us try to. So whenever liquid exerts a force on the bob, that is a buoyancy force it is experiencing, that is V sigma into G. This is nothing but a buoyancy force. Now whenever it is experiencing buoyancy force, what happened? The component, one of the component, it is always acts towards the mean position, that is mg sin theta, and another one is nothing but a V V sigma into G, both are acting towards the mean position always. So restoring force in this case, so F restoring force is equal to mg plus V sigma G into sine theta, V sigma G into sine theta. So this is nothing but a restoring force in this case. So what about the next content? So whenever restoring force we got, again theta is very small in this case. Whenever theta is very small in this case, then you have to consider that theta is equal, sine theta is equal to x divided by L in this case. So this is x, so F restoring force is equal to mg. So restoring force mg sine theta is opposite direction, minus here it is existed. So F restoring force, so mg minus V sigma G into theta. So now theta is, because since theta is very small here, theta is very small here, so it is equal to mg minus V sigma G into minus x divided by L, because it is a restoring force opposite to the displacement. So restoring force is equal to minus of mg minus V sigma G into x divided by L. Now let us try to compare this one with the standard formula of F is equal to minus k into x. So minus k into x is equal to minus of mg minus V sigma G into x divided by L. Let us try to cancel this one both sides. X will get cancelled. Then k is equal to m. Let us try. So G you have to take common in this case. So G into m minus V sigma into, so V sigma divided by L we will get here. So now the final step we will take, here, that is T is equal to, so T is equal to so then now what about the F is equal to, and in this case I was found here also. Instead of finding this one, what about the acceleration of the block? Let us try to take the acceleration of the block. Instead of taking K, let us try to take acceleration of the block. So acceleration A is equal to F divided by m. So A is equal to F divided by m. That is equal to, this is nothing but a restoring force. So m, let us try to take a common m in this case. So m into G minus V sigma divided by m into x divided by L. This is the actually force. So that is divided by m we will get here. This m and m will get cancelled. Then what about acceleration of the bob inside of the liquid? I am trying to find here. A is equal to, so G minus V sigma divided by m into x divided by L. This is the acceleration of the bob inside of the liquid. Now let us try to compare this acceleration with a standard equation of an acceleration of a particle. So let us try to compare the acceleration of the block inside of the liquid with a standard equation, that is minus omega. So what about the omega when you compare this one? So A is equal to the entire content G minus V sigma divided by m divided by L is nothing but a constant. Here omega square is equal to G minus V sigma divided by m totally divided by L. So omega is equal to square root of G minus V divided by M. Means you have to try to transpose this one, sigma by M divided by V, means mass by volume is nothing but an density of this is nothing but an density rho, density of a ball, sigma divided by rho divided by L. So this is the omega. Let us try to take a time period of pendulum. T is equal to 2 pi root with a standard content 2 pi root. So omega is equal to here also let us try to take a common G. You have taken common, otherwise I want to substitute directly, that is L divided by G minus sigma divided by rho. When you try to take a common in this G, so T is equal to 2 pi, so 2 pi square root of L divided by G, 2 pi square, I want to take on G is a common in this case, L divided by G into 1 minus sigma divided by rho we will get. This is one of the application of simple pendulum in simple harmonic motion. So omega is G minus V sigma divided by M into X divided by L, comparing with standard equation, it is omega, so this is correct, so G minus V sigma G by V sigma G. So here I was done a small mistake. This is V sigma G. So this is V sigma G. Sorry for the inconvenience. Here sigma G, here it is there. When you take a G common in this case, so G into 1 minus sigma by. What is this sigma? Sigma is nothing but a density of a water. This rho is nothing but a density of a bomb. So I will try to do one mains level problem based on this one, right? So
सर आप दाम
So how the problem will come based on this one? This is one of the IIT problem. The pendulum has time period T in air. The pendulum has time period T in air when it is made to oscillate in water. When it is made to oscillate in water, it acquires a time period, given the time period when it is oscillating in a water, that is T dash is equal to square root 2 into T. It acquires a time period T dash is equal to root 2 into T. The density of the pendulum of a bob, we have to find the density of a pendulum of a bob, means rho we have to find. And to find this one, he given density of water also. So density of water is equal to 1, he was given. So given the pendulum has a time period T in the air. When it is existing in the air, what about the pendulum of a bob? So the time period of a bob in air is T is equal to 2 pi root L divided by G. So this is the first equation. When the pendulum of a bob oscillates in water, so how I want to take the time period of a bob existing in water, automatically what happened, this is T is equal to T dash I am considering here. T dash is equal to 2 pi root L divided by G effective. This is second equation. What about the G effective? That is G dash or G effective I am considering here. G effective is equal to, we know just now we found, G effective is equal to square root of, so G effective is equal to G into 1 minus sigma divided by rho. 1 minus sigma divided by rho. Let us try to substitute that one. T dash is equal to 2 pi square root of L divided by G into 1 minus sigma divided by rho. So sigma, already this is the density of a water. Let us try to substitute that one. That is 2 pi square root of L divided by G into 1 minus 1 divided by rho. So this is the third equation. Let us try to divide equation 2 by 3. So divide second equation divided by third equation, that is T divided by, so T dash is equal to 2 pi root L G effective. That is first equation divided by third equation. Let us try. So first equation divided by third equation. T divided by T dash is equal to, T is nothing but an 2 pi root L divided by G divided by 2 pi square root of L divided by G into 1 minus 1 divided by rho. So 2 pi will get cancelled. What about the T dash? The time period of a simple pendulum in the water, it is existed, it is equal to square root 2 into T. Let us try to substitute in this case. T divided by root 2 into T, that is equal to square root of L divided by G divided by square root of L divided by G into 1 minus 1 divided by sigma. Now T will get cancelled. So L square root. So it is G will get cancelled. So let us try to square on both sides what you will get. So 1 by 2 is equal to, we will get here 1 divided by 1 minus 1 divided by rho we will get here. Then finally we will get square root of 1 minus 1 divided by rho we will get here. This is 1 by root 2 is equal to square root of 1 minus 1 divided by rho. Taken this one numerator, squaring on both sides for that one, what we will get? So 1 by 2 is equal to, remove the square root, that is 1 by 1 divided by rho. So 1 by rho is equal to 1 minus 1 by 2, that is equal to 1 by 2, then rho is equal to 2. The answer is, means the density of the bob is nothing but a 2 is the
ఈ
value.
ఒక్క ప్రాబ్లం ఒకసారి మళ్ళీ రిపీట్ ఎక్స్ప్లెయిన్ చేయండి.
Yes. So let us just once, I will try to revision this one. Let us try to take, this is one of the IIT problem. A pendulum has time period T in the air. We know this one. The time period of a pendulum of a bob, it is existing in the air. What about the time period? We derived already T is equal to 2 pi root L by G. Then the same pendulum existing in the water, what he given, the T dash time period is existed. That T dash is equal to root 2 into T. This is he given in the question already. And I was assumed the rho is the density of the bomb, what I want to find. And he given the density of the water is equal to 1 value. Now, the time period of the bomb in water, T dash is equal to 2 pi L divided by G effective. G will be changed. What about the G effective? Means G effective is equal to G into 1 minus sigma divided by rho. This we found already in the second application. Now let us try to take the time period of a bob in the water. T dash is equal to 2 pi root G effective. Let us try to substitute. Take T divided by time period of the bob in air divided by time period of the bob in water. Let us try to take the ratio. So substitute all the values. Let us try to cancel. So now next case, next step, you have to substitute. T dash is equal to root 2 into T. Let us try to substitute. T and T will get cancelled. Then 1 by root 2 is equal to square root of 1 minus 1 by rho you will get here. Then in the next step, squaring on both sides there, you will get 1 by 2 is equal to 1 minus 1 by rho. 1 by rho is equal to 1 minus 1 by 2, that is equal to 1 by 2. Then rho is equal to 2 we will get here. Means the density of the bob is nothing but a 2 in this case. So this is one of the IIT problem. and same type of problems we got in NEET program also. Thank you very much. Thank you.